Many of you know Vince Wislinski. He was a professor. He's now off doing bigger stuff. But Vince is a PhD mechanical engineer and a professor engineering at the U.S. Coast Guard Academy. Vince took a sabbatical from there a few years ago to help us really get things going up here inside First. And once again, we called on Vince like, hey, Vince, we need a really good way to jumpstart people, get them comfortable with this extraordinary new, very powerful control system. And like everybody else, at first, you ask somebody to do something, and somehow they do a spectacular job. Vince has done nothing short of a spectacular job of putting together a little preview, a little introduction to the new system. I'd like him to come up and tell you how it all works. Where's Vince? Vince!
Welcome to another exciting FIRST Robotics competition season. I'm Vince Wilczynski, a FIRST supporter from the U.S. Coast Guard Academy. The 2009 FRC control system is a really big deal. While your team's programmers may have already had their hands on your controller, we wanted the entire FIRST community to see the new system. Let's take a walk around some of its parts. The National Instruments C-RIO mobile device controller is the backbone of the system. The controller includes a 32-bit 400 MHz power PC and is programmable in either LabVIEW or C. Software and default programs are provided for each programming environment. 5 modules plug into the C-RIO to receive and transmit signals, and each module has a custom-made interface to optimize its use. 16 analog input signals can be monitored with NI9201 modules. Analog breakout boards provide easy attachment and 5 volts of power for your robot's analog sensors. A jumper on input 7 in slot 1 is needed to monitor the robot battery's voltage. NI9403 digital input-output modules and their associated digital sidecars allow 32 digital signals to be connected to the control system. The interface can be used with inputs such as sensors or outputs such as PWM connections to relays, motor controllers, and servos. Jumpers provide 6-volt power to each output that is connected to a servo. Speaking of speed controllers, there are 2 types this year: the IFI Robotics Victor and the Luminary Microsystems Jaguar speed controllers. Motor relay control is provided with IFI Robotics Spike relays. The NI9472 digital output module and breakout board supply 12 volts, 3/4 amp power on each of 8 channels. This interface allows you to directly power pneumatic solenoids with the controller, thereby eliminating the need to use separate relays to activate solenoids. The power distribution board provides power to all of your robot's electrical system. Wago connectors enable crimp-free connections and are a great feature of this board. A word of caution: metric size M6 nuts must be used on the lugs on this board. Using standard 1/4-20 nuts on the connection will permanently damage these metric lugs. Another electronic goodie is the Axis Ethernet camera that connects to the C-RIO with a crossover cable. Software has been written to readily use this camera for robot control. As a cautionary note, the enclosures for both the camera and the C-RIO are grounded. As such, make sure these devices are insulated from your robot chassis. An Ethernet cable connects the C-RIO to a wireless game adapter, thereby enabling 802.11n wireless communication between the robot and the driver station. Now for the driver's interface. The driver station supports up to 4 USB controllers. Analog and digital interfaces are also provided for custom-built controllers and indicators. An LCD screen displays parameters such as your team number, system status, and battery voltage. 2 USB joysticks are provided, and teams are free to use additional USB interfaces. Be careful not to turn on your driver station if the joysticks are not centered. The system automatically centers the USB signals during boot up, so it's important that the joysticks be in their naturally centered locations when the system initializes. When you're not at a competition, a dongle connection needs to be used to enable and disable the robot. Since the default condition is disabled, it might help to tether the dongle to the driver station to prevent it from getting lost. The wireless router connects to the driver station to enable communication with the robot. At competitions, the router won't be needed, with robot communication provided through the competition port. The FIRST website provides all of the control system details, including important instructions for updating your software and firmware. In addition to this site, National Instruments, WPI, and a host of teams are also posting important guidance to help you get the most out of your control system. The 2009 FRC control system is a result of an amazing collaboration between a legion of contributors. When Dean unveiled this system at the 2008 championship, he challenged the FIRST community to work together and build the world's best robot control system. As we now move into the competition season, teams are urged to continue to assist each other with this new technology and to make this year better than ever. Good luck and keep everything under control.